The moon has fascinated both scientists and non-scientists throughout history, and possible connection between the lunar cycle and organisms have been described since Aristotle. Lunar rhythmicity is widely observed in animal reproduction, such as spawning of corals and sea turtle nesting. Interestingly, human menstrual cycles, sleep wake cycles, and bipolar diseases are also synchronized to the lunar cycle. Hence, the lunar rhythmicity is fundamental to life functions. However, the mechanistic nature of lunar rhythmicity remains unknown. At the time of the spring tide, that is, new moon and full moon, thousands of grasshoppers aggregate and vigorously tremble and flop at the water's edge to spawn. This dramatic sight attracted tremendous general interest for a long time. However, the question of how animals synchronize their spectacular beach spawning to the astronomical lunar cycle remains unknown. To understand this mechanism, we focus on the wild grasshopper. I first organized a fishing team in my lab and visited the spawning site for fishing every week for 2 months during the breeding season.
Reproduction for the breed species is regulated by the hypothalamus pituitary gonad axis, and the gonadotropin-releasing hormone GnRH secreted from the hypothalamus is the master regulator of the reproduction. When we examine the transcriptome analysis using hypothalamus and pituitary, we identify the 87 springtide genes and the 38 leaptide genes, and the gonadotropin-releasing hormone 1 GnRH1 was identified as the springtide gene.
Furthermore, spatial transcriptomics and promoter analysis demonstrated that the springtide transcription factor CBPD regulated the expression of the semilunar gene GnRH1.
In addition to the GnRH1 and CBPD, we found activation of receptors for prostaglandin E2 at springtide. Since prostaglandin is known to act as a pheromone in freshwater fish, we predicted that PGE2 is acting as a pheromone. To test whether PGE2 is secreted during beach spawning, seawater was sampled at the spawning site. Using liquid chromatography tandem mass spectrometry, we detected PGE2 at the center of the spawning site.
To test the effect of PGE2 on puffer behavior, we prepared an artificial beach that mimics the spawning site in a laboratory. When we administered PGE2 into the tank using a peristaltic pump, both males and females started to show trembling behavior. These results clearly suggested that the pheromone PGE2, which is released into the seawater by spawning puffers, triggers the synchronized beach spawning behaviors observed in the surrounding individuals.
The mechanism that drives lunar-regulated rhythmicity remained a mystery in any organisms. Our study suggested that springtide transcription factor CBPD regulates GnRH expression and hence spawning behavior in grasshopper. The synchronization of reproduction to the lunar cycle is not limited to the organisms living along the shoreline. For example, wild beast mating and calf delivery in cows and human menstrual cycle are reported to be synchronized with the lunar cycle. Because CBPD gene is highly conserved in the animal kingdom, its role in the regulation of lunar rhythmicity in other animals is worth investigating in future studies.